Yeah, welcome back to this series on set. Now we'll consider certain types and the term set. It's basically a set of defined or an array, a pattern of defined objects. That's what set is. It could be arranged in another form, but they are defined. You can see the way they are written, the arrangement, the pattern. So that is what set is exactly. And I'm talking about the Venn diagrams here on that set. How you can represent information in Venn diagrams. There are different aspect or questions that you can do in that regard, but you need a basic understanding of representation of information in Venn diagram. Look at the examples we have. Let's represent some of these in Venn diagram. You have A complement intersect B. So let's say we have this to be A, this to be B, all enclosed here. This is A, this is B, and permits me to have something like our universal set is here. You have A complement intersect B. It means what is not in A, not present in A, but is intersecting B. Yes. So which means here I'm going to be having only this region shaded. Not in A, but is in B, of course. Intersecting B. What is that? It is that region. You have A complement intersect B. Every part of B alone. The intersection does not involve A. So you have it as A complement, not in A, but in B alone. And there's no intersection. So that's what that means. You have other ones if you have A itself, A complement alone. If you have A complement, so you have A complement, you can have something like this. So I call this A, while I call this B. So A complement will be what? Not in A, but it will be in B. So this region shaded is A complement. It's not involving A. We have other ones. You can have A union B shaded. You have A union B. Let me see, use this. You have this. This is A. This is B. A union B. It means everything in A and B. Union means everything in A, also in B. Every element you can find in the both. So you're going to be having this. Do you see that? That's A union B. What if you have A intersects B? A intersects B. What do you have? You have A intersects B. So I'm still using this. I have A inside. I have B here. Intersects B. What is common to both A and B? And that will be the region. Let me put A somewhere here. Now this is B. The bigger one is B. The smaller one is A. So their intersection will be this region. This is where both of them can actually meet. Yes. But if you talk about A intersection B here, let me wipe this. So you have this to be A intersection B. That will be this region. That's A. Have it be intersecting B. Let's talk about the second one. A intersects A complement intersect B complement. Not in A, not in B, but there's a intersect. The element not in A, not in B, but intersect, which actually means that will be the region where both of them are not operating. That is that region. So we have this maintain maintain this. Now where the both of them, this outside part, it's where A is not existing, and this also for B. So I can decide to wipe these two, then shade this whole region. If this is a region for A, not then this will be the region for B, not occurring. So this region now I can now put my B, A and B there. So that lower region that will be known as A prime intersect B prime. We have them on and on and on. We have other ones. If you have A union B prime, A prime. Do you see this? So what do we have? Get your A, get your A, get your B. But both of them is a prime. The union of both of them, but not there. It means union of A, B prime. Not involving their union. This region, these two, everything inside this place and everything inside this place is their union. But prime means not inside their union. Not inside their union. It actually means the region will be here. The region will be here outside. To be outside. To be outside. To be outside. So this is A union B prime. We have more. A union B union C. A union B union C. You have A union B union C. A B C. Which is A, it's B, this C. So A union B, A union C will be everything. All the regions enclosed in A and B and C. That's it. A union B, union C. If you have A intersect B intersect C, have A intersect B intersect C. What do you have? It means a region where you can have something in A and B and at the same time in B and C. something that's common to three of them, and this is just a region. That is a point of intersection. That is the point of intersection. We have more and more and more. If you have A prime intersect B prime, okay, intersect B, intersect C prime. A prime, we have a lot of them. Let me treat as much as possible so that you can have the knowledge of how to do this by yourself. You have A intersect, we have A in A prime intersect B intersect C prime. A prime intersect B intersect C prime. This means, okay, let me first draw that. You have this. 1, 2, 3. Just manage. Okay, let me draw this. A, B, C. A, B, C. So A prime. What's A prime? Intersect B, then intersect C prime. A prime and C prime are not involved. A outside A, outside C, then B is involved. Do you understand what that means? A prime is at B intersect C prime. Then it means only region B is concerned. Strictly B. Means no intersection. That's what it means. That's what it means. So we have them on and on. Stay close. Next video we'll treat an example on set. Thank you for watching.